Hello there, and thank you for joining me today for this lesson about multiplying and simplifying radical expressions. Our objective here is to multiply and simplify radical expressions of square, cube, and fourth roots. Previously in this course, we have simplified square roots. In the context of solving quadratic equations, we often solved using square roots, or we had a square root as part of the quadratic formula or completing the square, in which case we sometimes had to simplify that radical to put it in simplest form. And at that time, our ability to do so was improved if we knew some of our perfect squares by heart. Well, here now, as we move on to higher degree radicals, it's going to be helpful for us to know some perfect cubes and some perfect fourths. And I've got some listed on the screen here. Your ability to memorize them would be helpful, but not ultimately the key to your success here. You could always crank these out using a calculator or maybe some mental math even. But for the process of this lesson, it may be helpful to maybe screenshot this or have a list like this close by as we go through so that we can refer to this list and expedite the process of simplifying some of these radical expressions. So in a previous lesson, we simplified some radicals like these ones that have both constants and variables inside. But in that lesson, those examples we did were fairly convenient in the sense that everything simplified perfectly. We always had perfect squares and perfect cubes, and our shortcut for the variables worked out perfectly. Now that won't always be the case, and so I want to start here by practicing for that case. So let's first take a look at the cubed root of 16x to the fifth. We've been asked to simplify this radical expression. Well, 16 itself is not a perfect cube, and neither is x to the fifth. So the idea is to split both of those up so we can simplify as much as possible. So we're going to split the cubed root of 16 into two factors, and we're going to split up this x to the fifth in a way that will help us to simplify as well. But let's focus on the 16 first. The idea here is, just like it was in chapter 4, where we simplified square roots by finding a perfect square that factors into the number we're working with, the same thing applies here. So we're looking for a perfect cube now that factors into 16. So we could go back to our list of perfect cubes and try out a bunch, divide them into 16 until we find one that divides them perfectly. And one that will work is 8. 8 is a perfect cube, and 8 times 2 is 16. And again, we were looking for a perfect cube because we are working with cubed roots here. For x to the fifth, our division shortcut won't work perfectly because 5 is not divisible by 3 perfectly. There'd be a remainder of 2, which is itself kind of a shortcut. But back to the textbook way of simplifying this, since we're working with cube roots, we want to split x to the fifth into as many x cubes as possible. And I can do that one time, but there would still be 2 powers of x that I haven't used yet. And so I can split x to the fifth into x cubed times x squared. So now if we go right down the line, and I'm going to try to keep my work organized nice and vertically here, the cubed root of 8 is exactly 2. The cubed root of 2 cannot be simplified anymore. There's no perfect cubes that factor into it other than 1, which is not helpful. The cubed root of x cubed is exactly x. Now for the cubed root of x squared, just like the cubed root of 2, there's nothing that can be done there. When the exponent is smaller than the index, there's really nothing we can do to simplify this anymore. And so since 2 is less than 3, I don't have a chance of breaking this up anymore. Now everything that's not inside a cubed root can be put together to show multiplication. Everything inside a cubed root could be put together to show multiplication. And so here we have it, 2x times the cubed root of 2x squared. Let's try one more example from this slide together. Let's try a fourth root example. Here's the fourth root of 32x to the 8th y cubed. 32 itself is not a perfect quote-unquote fourth, so the idea is to split up 32 into 2 factors such that one of those factors does have a whole number fourth root. I'll worry about the x and the y in the moment here. So I go back to my list of perfect fourths, and I try to find one that factors into 32 perfectly. And 16 fits that. And 16 times 2 is 32. That x to the 8th, I kind of like where that's at already because I can tell my shortcut's going to work just fine. 8 is divisible by 4, and so I'm going to leave that alone and just use my shortcut here in a little bit. This y cubed, I'm also going to leave alone because this exponent is smaller than the index. And like we saw in the last example, I won't be able to split that y cubed up then in a way that would help me to simplify any further. So let's see what we have here. The fourth root of 16 is exactly 2. The fourth root of 2 cannot be simplified any further. Applying my shortcut here, 8 divided by 4 is 2. And so the fourth root of x to the 8th will be x squared. Again, 8 divided by 4 is 2. And the fourth root of y cubed is stuck the way it is for the reasons that were already said. So what do we have left? We've got 2x squared outside of the fourth root. Inside of the fourth root, we have 2y cubed. Be careful where you put your indices. If you let it meander too far this way, it might look more like an exponent. So keep that index tucked nice and close to that radical symbol there. So we can simplify radicals even if the math doesn't work out nice and neat and clean. We might have to deal with some remainders and get answers that look like these ones do here. For the purposes of keeping this video at least a little bit shorter than possible, we're going to go ahead and skip these two, and we can talk about them in person if you'd like. So at this point in our lesson, we've simplified a few radicals, and that will be part of the process we need going forward. But the next step is to talk about how we multiply radicals together. Now, we can multiply radicals together provided they're the same type of radical, square root with square root, cube root with cube root, and so on. And the idea is we multiply the terms inside the radicals together and any terms outside the radicals together, and then we simplify just like we did on the last slide. Typically, in my opinion, and you can disagree, it's typically better or maybe faster to do the multiplication first and then simplify. That way we do less simplifying than we might have to otherwise. But if the numbers get really big when we multiply or the exponents get really big, it may be helpful to break down and do the simplifying first and then multiply. The hard part there is we may end up having to simplify again, which is going to slow us down. So typically I'll multiply first and then simplify after. Once again, in an effort to keep this video a little bit shorter, let's skip ahead to these examples here. We've done square roots in the past, so let's try doing the cubed root in the fourth root example here. So let's zoom in on this one. Here we have two cube roots that we've been asked to multiply together. The idea is to multiply the stuff outside the cube root together and then the stuff inside the cube root together. Well, outside of the cubed roots, I see a -1 and a +2, and -1 times 2 is -2. Now, inside the cubed root, let's see what we have. We've got 2 times 16, which is 32. We've got x squared times x to the 5th. When we multiply those terms together, we add the exponents and get x to the 7th. We've got y squared times y to the 1st. When we multiply those terms together, we add the exponents and we get y cubed. So there, the multiplication part of this has been done, but now it's up to us to simplify what's left over. Let's just leave the -2 in front alone for the time being, and let's focus on what's inside. So like we practiced on the last slide there, we've got to split 32 up. 32 is not immediately a perfect cube, and it's always good to check right away, but 32 itself is not on our list of perfect cubes, so we're going to have to break that up. Okay, so we look back at our list of perfect cubes, we try to find one that factors into 32, and you have to shift your mindset to make sure you're focusing on the right type of radical. We would approach this differently if we were doing, say, a square root example or a fourth root, but we look at our list of perfect cubes. 8 is a perfect cube that factors into 32 4 times. Now for that x to the 7th, I'm going to split that up in such a way where I can use my shortcut as much as possible. And 7 is not divisible by 3, but 6 is. So I'm going to split this into x to the 6th times x to the 1st, so I can apply my shortcut here, and I'll do that in a moment. For this y cubed, that's going to play out quite nicely since we are working with a cubed root after all. So if we work from left to right now, let's see what we have. We have -2 times the cubed root of 8, which is exactly 2, times the cubed root of 4, which is what it is. Can't do any more with that. The cubed root of x to the 6th, Well, 6 divided by 3 is 2, and so I get x to the power of 2 there. The cubed root of x to the first is stuck with that exponent being smaller than the index, and the cubed root of y cubed is exactly y. My work got a little bit shifted there to the left, and I apologize, but this is kind of how it's supposed to be stacking up here. So everything that's no longer inside a cubed root could be multiplied together. We've got negative 2 times 2, which is negative 4. We've got an x squared and a y to the first. Inside this cubed root, we've got a 4 and x to the first. It's easy to forget that index. It makes a difference whether we're working with a square root, a cubed root, or a fourth root. So take care to always write that index down. The only time we really omit it is when we're working with a square root. You could put the 2 if you wanted for a square root, but mathematicians usually save time by not doing that. One final example here. Let's try this fourth root example. I'll try to speed things up perhaps a little bit here. We start by multiplying any coefficients outside of the radicals. We've got a 6 times a 1, and 6 times 1 is 6. Inside of the fourth root, we have 8 times 4, x cubed times x to the 6th, y to the 7th times y to the 3rd. So there the multiplication has been accomplished. 32 itself is not a perfect fourth, quote unquote. We should always check that, right? But the idea is then to split 32 up into 2 factors where one of them is a perfect fourth. And we go back and we look at our list, and 16 is on that list, and 16 times 2 is 32. Moving on to the x to the 9th. I like using my shortcut, and so I'm going to split that up in such a way where I can apply that shortcut. 9 is not divisible by 4, but 8 is. And so I'll split x to the 9th into x to the 8th times x to the 1st. Similarly, for y to the 10th, and I have just enough room, I think, I'll split that into y to the 8th times y squared. Still have 10 powers of y inside of a fourth root there, just splitting them up so I can use my shortcut. Going down the line now, all of this is connected via multiplication, remember. The fourth root of 16 is exactly 2. The fourth root of 2 is stuck. Let's see if I can keep this vertically aligned a little bit better. My shortcut here, x to the 8th, the fourth root of that. 8 divided by 4 is 2. The fourth root of x to the first is what it is. Here again, the fourth root of y to the 8th would be y to the power of 2, using my shortcut. And the fourth root of y squared is what it is. That index is smaller. The index is bigger than the exponent. So what do we have? We've got 6 times 2, which is 12. We've got an x squared and a y squared here. Inside the fourth root, it looks like we have a 2, an x, and a y squared. So when we multiply radicals together, multiply any coefficients outside, multiply the terms inside, simplify the result if possible, like we have done in these examples here. So our objective today was to multiply and simplify some radical expressions. We did that with square roots, cube roots, and fourth roots. Thank you for watching.